A spacecraft flew through another world's ocean. Nobody knew the ocean was there. Break time equals 500 mens. Nobody planned for it. What the instruments captured has still not been fully explained. The gravity matrix. Cassini flew through another world's active ocean. Break time 400 mens once. Here at the gravity matrix, we track every major dataset. What the chemistry reveals is more disturbing than fiction. We need to confront what Cassini actually found here. This signal defied every prediction made before 2004. William Herschel saw Enceladus in 1789. Nothing prepared us. Voyager flew past in 1981. The surface looked impossibly fresh. Albedo 0.99. The most reflective surface in the solar system. That albedo meant the ice was continuously renewed. A moon the size of Arizona, no known heat source. Planetary models in 2004 predicted a frozen, geologically dead world. Cassini arrived at Saturn in 2004 and turned south. What the infrared data showed shattered the prediction immediately. Cassini's imaging team saw 4 parallel tiger stripes first. Each stripe, 130 kilometers long, 500 meters deep. The stripes were warmer than models allowed. Far warmer. 15.8 gigawatts radiated from those fractures, 20 Yellowstone geysers. No tidal model could account for that energy discrepancy. And in 2005, plumes, rising thousands of kilometers above. Dr. Porco said nobody spoke for a full minute. The plume fed Saturn's E-ring, an ocean-made ring. The E-ring is made of Enceladus. Every particle. That ring has been replenished for billions of years. Enceladus vented its ocean across entire geological timescales. The question that followed changed the entire mission's priority list. What is driving those plumes from the inside? The INMS instrument was built to taste plumes directly. In 2008, Cassini flew directly through the plumes. A direct sample at 14 kilometers per second. Dr. J. Hunter Waite Jr. at SWIR-I led the analysis. The first confirmed detection, water vapor, exactly what was expected. The second detection, carbon dioxide and methane, organics, unexpected. The third detection stopped the team cold, molecular hydrogen, 2 at 0.21.4% of total plume gas. Molecular hydrogen is thermodynamically unstable. It should not persist. It reacts away rapidly unless something is continuously producing it. One geochemical process on Earth produces hydrogen this way. Serpentinization. Hot water reacting with silicates releases hydrogen as byproduct. Serpentinization requires temperatures above 90 degrees Celsius. Active contact. The hydrogen signal was direct evidence of hydrothermal vents. Vents operating beneath 40 kilometers of ice. A global ocean. Waite's 2017 science paper title was precise and unambiguous. Cassini finds molecular hydrogen in Enceladus. Evidence for geochemistry. What geochemical processes? The paper was careful about this distinction. Geological, biological. Both produce hydrogen in this context. Cassini could not tell them apart. The story gets complicated. If those vents run the same life-sustaining chemistry. If this shifts your view, subscribe to stay briefed. 6 elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. CHNOPS. Everything Earth life requires to exist. Carbon in Enceladus plumes, confirmed. Nitrogen, confirmed. Oxygen, confirmed. Sulfur confirmed in recent reanalysis, hydrogen confirmed in 2017, phosphorus was the holdout. The original data could not confirm. Phosphorus is DNA's backbone. Without it, life cannot start. In 2023, Waite's team reanalyzed the full Cassini INMS dataset. The phosphate signal was there, buried in years-old data. CHNOPS complete. All 6 elements present in an active plume, the same 6 elements that build every cell on Earth. This result alone would normally justify a follow-up mission. But silica nanoparticles had already proven the case in 2011. Dr. Frank Postberg at Free University Berlin identified silica particles. Silica particles that size form only above 90 degrees Celsius and only in alkaline conditions, pH 8 to 11. The same pH range as Earth's Lost City vents. Lost City was found in 2000, already teeming with life. No sunlight, no photosynthesis, life running entirely on serpentinization chemistry. Same chemistry, confirmed on a moon a billion miles away. Everything changes here. This is no longer a geological story. Hydrogen, methane, vents, pH, defining a specific metabolic niche, methanogenesis. The oldest known metabolic pathway on Earth. H2 plus CO2 yields methane plus water, the complete reaction. Methanogens live oxygen-free. They use hydrogen as primary fuel. Dr. Everett Schock at Arizona State modeled Enceladus methanogenesis thermodynamics. The reaction is thermodynamically favorable in Enceladus ocean. Energy positive. If methanogens exist, the chemistry is already running. Cassini detected both H2 and CH4 simultaneously in the plumes. This ambiguity cannot be resolved from Earth. Not yet. Geological serpentinization produces methane too. Without biology, hydrogen isotope ratios would distinguish them. Cassini lacked that resolution. What Cassini confirmed, the energy source is viable, continuously running. This makes Enceladus different from every other ocean world candidate. Europa has an ocean. Its seafloor composition remains unknown. An ice-floored ocean cannot do serpentinization. Water never touches rock. Enceladus confirmed rocky silicate seafloor. Silica nanoparticles proved it. The plumes gave direct ocean access, without any drilling. No drilling, no lander, no complicated icy surface landing. The ocean brings itself to the spacecraft. Unprecedented in astrobiology. We sampled another world's ocean. Cassini did it 5 times. Cassini mission ended September 2017 with a planned Saturn plunge. Deliberate decision to prevent contamination of Enceladus or Titan. Dr. Linda Spilker, Cassini project scientist, described it as bittersweet. The spacecraft was gone. The data remained, still producing. 8 years of subsequent analysis continued to yield landmark discoveries. Cassini gave us the forensic chemistry of a habitable candidate world. The chemistry was measured directly, instrument by instrument, not modeled. INMS confirmed gases. SIARs confirmed thermal signature. VINS confirmed organics. 3 independent instruments. Same chemistry. That is not noise. Data quality unprecedented for any solar system body beyond Mars. Ingredients, energy, solvent, time, all 4 present. That is not a life guarantee. Responsible science acknowledges that. Data consistent with life, also consistent with active geology. That distinction is the most important unanswered question in astrobiology, and we have the capability right now to answer it. The capability we have, the mission has not yet launched. Here is what to watch for in the 2030s. Enceladus Orbilander was the top NESL Decadal Survey Priority Recommendation. That survey shapes NASA mission priorities for the next decade. Orbilander would carry instruments 100x more sensitive than Cassini. It could detect individual amino acid molecules within the plume. Amino acids build proteins. Finding them would not confirm life. It would confirm chemistry running in a direction we recognize. Enceladus has an active ocean, hydrothermal vents, CHNOPS complete. The 2023 Decadal Survey calls Orbilander Priority Mission. mass spectrometers 100 times more sensitive than Cassini, capable of detecting individual amino acid molecules in the Plume. It has not launched. The question sits in a document. What would confirming life mean? Full breakdown in the comments. Dr. Jonathan Looney at Cornell has been the loudest advocate. His argument, Enceladus cost-benefit, is the best case in astrobiology. No landing on a difficult surface. No drilling through ice. The ocean comes to us. No other world does that. The Cassini team spent 8 years mining mission data afterward. The 2023 Phosphorus find came from 8-year-old data. New algorithms extracted a signal that was always there. Missed. This is what deeper analysis of existing data reveals. The next mission knows exactly where to look. That is perhaps the most important legacy of Cassini. Not the data it returned, the roadmap it left. Now step back to the scale of what this means. Our galaxy has 200 billion stars with potential ocean moons. If Enceladus hosts life, it was never about one moon. The principle: life does not require a star to survive. Rocky moons in outer systems warmed by their gas giants. The habitable zone is anywhere liquid water exists, anywhere. Enceladus may have expanded the universe's addresses for life. Not speculation, a direct logical extension of what Cassini confirmed. The preprint status caveat: the phosphorus detection awaits independent confirmation. Hydrogen and vent chemistry were peer-reviewed. CHNOPS completion is provisional. Science requires we hold both the excitement and the uncertainty. Cassini told us what to look for. Orbilander confirms it. We have been waiting since 2005 for that follow-up. The evidence accumulated for 2 decades. The proposal was written. What Cassini found in that frozen snowball rewrote habitable. Its data is still being analyzed, still producing open questions. That frozen moon may not be alone in the galaxy. Next time you see Saturn, remember what Enceladus ejects. An ocean, active chemistry, answer within reach for 2 decades. Full investigation of Enceladus chemistry is linked in the description. We track every Enceladus update. Subscribe, watch the launch.